Hello interwebs, welcome to Let's Fix Computers. I've got a HP 15BS series laptop here that doesn't power on. I've got a charger plugged into it at the moment, but there's no light at there's no charge light at the charger jack, and it doesn't want to turn on at all. Lights don't come on, push the power button, nothing happens, etc, etc. It's stone dead. So let's open this thing up, take a look, and see if we can figure out why it doesn't turn on. Okay, so the inside of this thing is pretty clean, all things considered. No explosions in sight so far, which is a good start. It still has a hard drive in it, gross. 4 gigs of RAM. 4096 on the back, yeah, 4 gigs of RAM. I mean, that RAM looks a little bit tarnished as well. It's not dreadful, but you can see in the light there that it's not perfect. That's not going to stop it turning on, though. It might stop it from posting, but yeah, that's not going to be our issue yet. Alright, whatever. What about our BIOS battery? I'm going to check on that. Again, I don't think that would stop it. That's not going to stop us from getting a charge light, but I'm just profiling this thing. And our survey says a bad ground. Right. Just shy of 3 volts. Okay. That's flat. That's functionally flat. Because the other thing to remember is we're 3 volts at the battery, but it's also got to go through a diode before it actually gets into the PCH, which is where that voltage goes to. And you're going to lose a little bit more voltage in that diode. Even if you're using like a Schottky diode, you're still going to have some losses. So even though we've got, you know, just about 3 volts at the battery, it's going to be even lower than that by the time it gets to its destination. So I'm just going to quickly shove another one in there and just see if that magically makes the laptop decide to come back to life. And our survey says no. Nope, still no light on the charger. Okay. After each test, I'm also just unplugging my charger and then plugging it back in again, just in case it's causing the charger to cut out, because that's not uncommon. Right. Let's get the multimeter under the multimeter camera. And let's see what's going on in here. We're going to check for some obvious shorts first. The motherboard's probably going to have to come out, but I'm just going to do a little bit of just stabbing just to see what to expect here. So I'll put my black probe on any bit of metal as a ground or a screw hole or something. And I'm going to stab, let's see. There's not a lot on this thing, actually. Let's find some nice big capacitors, like these big electrolytics. Those are all 2.5 volts. That's not going to be it. Well, let's start at the DC in jack here. So the DC jack is over at the hinge, and the wire comes around and plugs in here. We've got some red wires, some black wires, and some sense wires, as well as the LED and stuff like that. So let's check the red. And, whoops, we're falling off of it. And we're seeing, you know, like 500,000 ohms. So yeah, that's not shorted. Right, are there some nice big looking main rail looking capacitors around here we can stab? I'll just stab some of these anyway and just see what happens. Okay, well that's a capacitor, positive leg, and that's showing 0.5 ohm. So this capacitor here has got 2.5 volts written on it. So we know that that can't be on the main power rail because it's not rated high enough for the main power rail, which is 19.5 volts. This one doesn't have a voltage rating written on it. It will be in the text somewhere, but I'm not very good at reading codes off of things. The point is, it's different. So we can make a reasonable assumption that this one is on a different rail. So this one is our input capacitor, and we're seeing 0.5 ohm of resistance on it. So if I just probe that again, I've got my probes the wrong way around, but it's shorted, so it doesn't matter. So there's 0.5 ohm there. However, the pink one here, the pink capped one, that one was showing 19 ohms. So that 19 ohms we're seeing, that is the low resistance through the CPU. And low resistance through your CPU is completely normal. It's why all of the capacitors on the back of the CPU look like they're shorted out. That's completely normal. This is why we don't use beat mode. Because if I put my multimeter into beat mode or continuity mode, so it beeps when the probes touch, people often use this for short detection. So if I put my black probe on ground and I touch another ground, it beeps. So if I touch this one here, it beeps at me. However, that's 19 ohms of resistance through the CPU. That's not a short circuit, but beat mode will make you think you're shorted. So this is why we don't use beat mode. I know it's very tempting, and I know it's cozy because you can just stab around and wait for a beep, but beat mode will deceive you, so stay off of it. Anyway, so this guy here is showing half an ohm. So that's probably our main power rail, and it looks like we have a main rail short. However, there's very little else to see on the top of this board. So let's get the board out so we can have a closer look, and we'll see what we can find. I've got a horrible feeling there's not going to be much to see on the bottom either. It's a pretty Spartan board, this. I believe... do I even know what CPU is in this thing? It's a Core i3. Yeah. For a moment, I thought it was going to be a system on a chip or something like that. Because SoC laptops, where everything is integrated into the CPU, there's often just very little on the motherboard, which is why SoC laptops exist. Because they're cheap, like the budgie. However, on this one, yeah, there's just not a lot going on here. Anyway, I'm going to stop waffling and pull this board out. Okay, so let's flip the board over. And, okay, yeah, there is actually a fair amount going on the back here. Here's the rest of the power stuff that I was looking for. We've got all of the battery stuff down here. There's some big MOSFETs here. Those must be our CPU V-Core MOSFETs. Because I couldn't see those. Like, we had a coil here, and we knew that V-Core was around here somewhere, but I was like, where's the rest of it, man? So, there's our V-Core MOSFETs, and there's a bunch of stuff up in this corner, I/O stuff and things like that. It all looks pretty tarnished. It's it's getting old, this laptop, basically. Arguably not worth the board repair, but I like to work on them anyway if I can. If I think I've got a chance of fixing it, I try to do it anyway because practice. The only way you're going to get better at something is doing it, you know. Lewis Rossman often said, you know, how to get started at board repair. Find a broken board and try and fix it. Okay, so the next thing I want to do is I want to check the secondary power rails because certainly in recent times we've had a couple of repairs where we've had short circuits on the main power rail that were caused by a secondary rail failing, such as the 5-volt rail or the 3.3-volt rail, which in turn have had their own causes for failure. So I'm going to go around and just stab any other power supplies I can see. So I'm looking for big inductors. So the grey squares on the board, any grey square, that is a large inductor, which means there's some kind of voltage regulation going on there, the vast majority of the times. So I'm just going to stab all the other inductors. So this one here, this one is V-Core. We know this is okay already, but we'll just look at that again anyway. So there's about 30 ohms. I'm not getting very good probing on that. Let's just go on to an actual screw hole instead of the HDMI port. There we go. With a better ground, we're getting a more accurate result. Okay, right. What about this little one next to it? That's probably some kind of secondary rail. 50 ohms. Okay. This guy down here looks like the battery charger. Just off shot down here. Yeah, 100 kilo ohms. I'm not looking at specific values here. I'm looking for something that's just like short. So yeah, 62 ohms. Remember, we've got a dead short on the main power rail, so we're looking for 0. 423 ohms. 2 kilo ohms. That guy there. Yeah, 5 kilo ohms. Okay. Oh, there's another one here. Let's grab that guy. $23 ohms. I've had my probes the wrong way round, by the way. That was just a mistake, but it doesn't matter too much because we're looking for shorts. That was not deliberate, though. Okay. So I'm not sure which one of these secondaries are our 1 volt, 3.3 volt, and 5 volt rails without looking them up. It's not very clear on this board, but I'm not seeing anything else that looks screamingly shorted. So I might take a punt. I might take a punt and go straight to injection on this one. We've already checked for a short on the CPU, and we're not shorted on vCore. So if we inject, we're not going to go into the CPU. So before we go to injection, I want to take a look at how the main power rail gets created and goes up to where we're seeing that short. That means that A, I can probably find a nicer place to inject on, and also I can just sanity check that what we're seeing is what I think it is as well. And it's good practice to learn how to read the board input instead of just making assumptions. So let's start down here at the DC jack input. So I'm going to swing in under the microscope now because then we can see the close-ups. So there's the DC jack, and as you can see, the pins on it don't really seem to go anywhere. There's no obvious traces coming out from these pins, and it's all going just under the connector. So let's flip the board over, and on the other side we can see these vias that are coming through the board. So these are our positive power pins from the DC jack, and they're immediately going through an input inductor, which just helps suppress static and inrush and just the sudden jolt when you connect the charger and that kind of thing. And then we immediately go into the DC in MOSFETs. So these guys, on MacBooks, they're known as the inrush limiter. So I just often refer to this as the inrush limiter, but a lot of people just call it DC in MOSFETs. So we've got these guys here, and we're going to go through one straight into the other, and then the output goes through this current sense resistor, and then this then becomes our main power rail. So the output here is the main power rail. So if we measure here, we should see our short circuit. So let's do that. I'm going to turn the board around just so I can get it flat on the table. So we've come through our DC in MOSFETs over to here. So I'll put my black probe on a ground plane again, and we're just going to measure there. And we should see our half ohm short circuit. Okay, that's not a very good reading. Am I getting just really bad probing here? Let's try the back of the MOSFET itself. The current sense resistor is basically a dead short. There we go, there it is. Okay, so we were getting bad probing there, and that's because there's often just schmutz and stuff on the solder joints. They've often got just a coating of just very light tarnishing and old flux residue and that kind of thing on them. So I'm just going to stab through that a bit harder, and then we should see something that makes sense. There we go, there it is. So again, just a lesson in just being a bit wary about your probing there. Okay, so we've come out of there, and as you can see, this trace here, it's got a thin trace going up in this direction. That's not going to be doing, that's going to be like going to monitoring or something like that. It's probably going to go to the EC or the power management chip or something like that. That's not our main power rail, it's too thin. However, in the other direction, it's got this big fat trace that goes through here and goes through a whole cluster of vias going through the board. This MOSFET here is going into the battery charger. So here we have, this area is all to do with battery and charging thereof. This is probably not our issue, but you know, we can check that for funsies. If we just measure on this area, you can just check if there's anything going on there. And we're seeing 22 kilo ohms there. So there's no short circuit here. So this guy is closed, it's a barrier. our short circuit is not up here at all. So let's follow these vias through the board and flip over again. And this is where we hit a dead end. So those vias are coming up here, but as you can see, they're not going anywhere. So this means we've connected to an internal power plane, one of the inner layers of the board. We can't follow this unless we already know where it goes. So I could spend a lot of time staring at the board looking for where the main power rail pops up somewhere else, but to be honest, we've already found the source of the main power rail here and the current sense resistor. This is generally a good place to inject when you have a main rail short. So that's where I'm going to attach my leads. Right, so I'm going to go for the stab method this time, just to save time on soldering jumper wires on, because I think this one's going to be simple. I think we're going to see a capacitor light up somewhere. So I've got a ground clamp here to my power supply that I've just clamped onto this big old screw hole here. So that's got a nice copper connection there. I'm just going to make sure that's nice and settled. I've got my thermal camera ready, my Infrared P2 Pro. And I've got 1 volt and 3 amps dialed in, and I'm just going to stab the board on the main power rail. So let's turn on the power supply. So we've got 1 volt, and we're passing no amps. And when I hit the short circuit, we're going to see the voltage drop down. Okay, here we go. And stab. I'm not getting a very good connection there. We're still at 1 volt and 1.2 amps. However, we are seeing a hot spot. Okay, let's come off of that. That on the other side of the board. I'm going to go for the close-up. Let's do that again. Yeah, that's definitely on the other side of the board. I think it's going to be one of these guys up here. Right, so I'm going to stab our shorted capacitor this time because we know that the short is there. Oh, there we go. Beautiful, beautiful heated cap there. There we go, there's our fella. I always wondered to myself if it was already cracked or it cracked after I pumped 3 amps into it. However, it's definitely gone now. And the funny thing is, like, it's never where you expect it to be, because if we look on the other side of the board, where was that bad area? Down here. Like, look at the state of all these caps. You know, you can do a visual inspection, but the problem is if you point out every tarnished cap, look at the state of all these guys. They all look tarnished. By comparison, the actual one that's failed, apart from the crack, it's not tarnished at all. It looks completely fine. Its next door neighbor looks completely fine. It's only when you see that crack that you know that there's a problem. So this is the thing, is that you can look at tarnished components and components that look discolored, and you can be like, wow, that doesn't look very good, but it's not always the problem. So I wonder what this is actually doing. This is some kind of voltage regulator here. We've got a power regulator, and we've got some there's another power regulator with a so there's a regulator chip, an inductor, and some capacitors here for it. This is going to be one of the secondary power rails. No idea which one it is. It might be DDR because we're next to the memory modules, but I'm speculating wildly there. Either way, let's get that out. So I'm going to remove both of those capacitors because then I can measure the working one. I'll bet money that these are going to be 10 microfarad because it's always 10 microfarad. But we'll measure one of them and then we can be sure. Just get some fresh solder on each side. That'll do. Now let's see if I can be very cheeky and just stab these. Oh, I don't think it's going to let me. Well, this is very embarrassing because normally at this point I'd go for the dual wield and get a second soldering iron. However, in a horrible twist of fate, both of my pine sills have died at the same time. I'm currently using my backup iron, which is the Secure S60. I've got a TS100, but that's at home. So, come on, I don't want to use hot air here. There's connectors and capacitors all around. Heck, alright, hot air it is. I'm going to use a smaller nozzle, and I'm going low airflow and higher temperature, going in at 450 on low airflow, just to see if I can zero in on those capacitors. There's one. The good one is free. The bad one has welded itself to the board. There we go. Good. Precision hot air. Right, let's try and measure those capacitors. See if I can avoid having to go and get my transistor tester. So one of these guys is mega dead. Which one was cracked? That's the cracked one. Oh, damn it. Come on. That guy was glued down in a puddle of flux. Time to get schematics, folks. It's going to be 10 mic. I know it's going to be 10 mic, but we want to show that it's 10 mic. Show, don't tell. How is anyone supposed to know what it's supposed to be if you don't show how to find out? Right, this board is an LA E79-1P. Schematics acquired. Wow, this thing's DDR4. Yeah, so it is. It was a modern potato of its day. Okay, but seriously. Alright, so before anyone asks in the comments, oh, where did I get schematics from? I Google searched. I Google searched LA-E791P space schematic. And the top hits are bad caps because the bad caps guys are legends. So if we look at the board where we just pulled off those capacitors, that was up there. Let's look at some nearby components. So that regulator we were looking at, the control chip for that is PUM1, and the inductor is PLM1. So let's search for the inductor because we know that those capacitors were directly connected to it. So PLM1. What am I looking at here? PLM1. There it is. God, this is not a very good schematic. Right. PLM1 looks like the 1 volt rail. What's the controller nearby? PUM1. So yeah, we're on the correct controller. And hey, look at that. I was correct. DDR. This is the DDR regulator. Right. This schematic is not very clear. This is not a good, clear example of what the regulator should look like. But I think we can probably figure out what's going on from here. So I was wrong. It looks like they're it looks like they're 22 microfarad capacitors because there's a whole bank of them here. We didn't see that many on the board. Are there ones on the back as well? Yeah, so on the back, here's our regulator here, and on the back of the board, there's another bank of caps there. I have a suspicion that that's the rest of the capacitors. There's half on the back and a couple on the top. That's a guess, but this makes sense. These are all 22 microfarad capacitors, 22U. So U is micro, and they're 0603, 6.3 volt. So that all makes sense. In my defense, we probably would have gotten away with 10 microfarad capacitors because it's got a whole set of 22 mics on the other side. But either way, I also have 22 mic capacitors, so we'll put those on instead. So let me grab some. 22 microfarads. Let's bust a couple of these out. So we're going to replace both of those capacitors because one of them is cracked and the other one is somewhere on the floor. And I'm buggered if I'm going to go look for it. Not when I have lots of spares. Right, sorry folks, but I cocked up and I left the schematics view open over the top of the microscope view while recording, so we have no microscope view for what I'm doing here. But the short answer is, at this point, I used a bit of alcohol to clean up the motherboard where I'd removed the old capacitors, and then I used the hot air to just quickly reflow the new capacitors into place. It was extremely straightforward here, just a little bit of hot air just to flow them back on. That's all was needed. So let's pick up just after I've finished doing that. Okay, right, let's just drop this straight back into the chassis and it's probably gonna work. However, as a special treat, I'll actually just, make sure we're not shorted still. We'll just do another quick stab in the same place that we were previously checking. There we go. 500,000 kilo ohms. Wait, 500,000 ohms. 500 kilo ohms. We're done. We win. There we go. Now we've got a light at the charger. And if I push the power button, we have fan spin. We have a power light. And we have a HP logo. The hard drive just span up. It's probably RAM training, because it has had a BIOS reset because the BIOS battery was removed. Did I plug in the screen? Yeah, I did. Let's just be patient. Okay, it just cut out. Let's come back on again. And again. There we go. This is why we're patient, people. That was a real long RAM training and post time. These things will make you think that they're still broken, but sometimes you got to wait. Good, so that was a CMOS reset thing. It's just disappeared before I could look at it, but the point is it started. So I'm going to unplug this. Actually, I'm going to wait for it to actually hit. Boot device not found. That's not great. Okay, we'll come back to that in a sec. I'm going to disconnect it. Check our connections. That looks good. I'm going to be livid if this thing has got a bad hard drive in it as well. In the conclusion for this video, I was going to talk about how this laptop probably wasn't worth doing board repair on because it's got 4 gigs of RAM and a spinning drive in it, which means to get a good user experience out of this laptop, it needs at least an SSD and another 4 gigs of RAM, as well as the board repair. This laptop is technically a write-off. However, I've gone through with it anyway for the sake of the content. But if the hard drive is actually full failed, Because my intention was just to knock this one out for cheap and just be like, look, this laptop is probably past it, but I got it working for you, you know. However, if the hard drive has also failed, I'm going to be extremely sad, because then I can't even knock it out on the cheap. I still have to write off the laptop, even after I fix the damn thing. Right. I've just booted the laptop from a Windows flash drive, opened a command line and gone to disk part, and it is detecting the hard drive just fine. What's going on here is, because we reset the BIOS, it has defaulted to UEFI mode, and in all likelihood, the customer's hard drive has an old legacy install of Windows on it. I had a quick sneaky look at the partitions on this, and it's got a very weird partition set up on it. That no hard drive found error message, this is a software issue. The laptop itself works, so that means we win. So I'm going to put all this back together again, but you guys don't need to see me do that. This is all fixed, so thank you everyone for tuning in, and I'll see you in the next video. Bye for now.